This is Devasis Raut. So today we are meeting to learn on the subject JVM architecture. So JVM you all know that is Java Virtual Memory. Okay, it's not a permanent memory like we see in our computer or PC like C drive, D drive, all these things, but it's a temporary memory. Okay, so JVM we all know. What is JVM? Okay, the color. JVM Java Virtual Memory. Okay, so we are here to learn how a JVM memory structure is created when we are executing a program. Okay, so without wasting any time, we should move forward. Like basically, like I can say, JVM have like five spaces, five areas are there in the JVM. Okay, those are like in JVM, five areas are there. One is like method area, another one is like heap area, another one is like Java stack area, another is program counter registers area, and the last one is native method stack area. Okay, it is stack method stack. Okay, so among all these, only these three method area, heap area, and Java stack area will be our concerning part. Okay, rest are also there, but we are not going to read on that. Okay, so like I was telling, so what is you from the definition of the from the full form of the JVM, we learned that it's a Java virtual machine. So what is virtual machine? So what is the original meaning of virtual machine and what is Java virtual machine? So we will read these things, then we will be proceeding to the method area, heap area, and Java stack area, and how and a program we will write and how the program will be executed in this area. We will be reading this. Okay. So this I will complete in this session only. Okay. So what is virtual? What is virtual machine? Okay. In general terms, virtual machine is a software that creates an environment an environment between the computer platform and end user, in which end user can operate programs. Okay, so virtual machine is what? Virtual machine is a software that creates an environment. Okay, so it creates an environment between the computer program, sorry, computer platform. Okay, platform which the computer have and the end user, in which end user can operate the programs. Okay, so if we will go for what is really the virtual machine, so in detail if we are going to learn this. So the thing will be that virtual machine. So virtual machine as per the functionality meaning. Okay, as per functionality is creation of number of different identical execution environment on a single computer to execute programs. Okay, this is the in detail. If you know that as per the functionality terms for the virtual machine is creation of number of different identical execution environment on a single computer to execute programs. Okay, so what is like we know about the virtual machine. So what is Java virtual machine? So what is Java virtual machine? Okay, so it is also a virtual machine that runs Java bytecode by creating 5 identical runtime areas to execute class members. Okay, this bytecode is generated by Java compiler in a JVM understandable format. Okay, so it is also a VM, okay, that runs Java bytecode by creating 5 identical runtime areas to execute class members. Okay, this bytecode is generated by Java compiler in a JVM understandable format. Okay, in a, okay. So if we will move forward, what is method area? I told you we will be concerning 3 parts will be there. The concerning like method area will be there, heap area will be there, and Java stacks area will be there. Okay. So what is method area? All classes. You know about bytecode, huh? What is bytecode? Like we have the Java format is that dot Java is there. Like we write a class like example class, then that file will be named as example.java. So when that class will be compiled, then that class will be formed. The dot class which it is formed, that one is the bytecode of the example class. Okay, so like that is the bytecode. All classes bytecode is loaded and stored in this runtime area, and all static variables are created in this runtime area. So we knew that so in the method area classes bytecode is loaded and stored. Okay, and also static variables are created in this runtime area. Okay, we got that clarity and we'll see through the example. Okay, then you will be clear. Heap area, it is the main memory of JVM. All objects of classes like non-static variables memory are created in this runtime area. This runtime area memory is a finite memory. Okay, this area can be configured at the time of setting of runtime environment using non-standard option like this one, Java, then hyphen XMS, then the size will be there in this, then class name will be there. Okay, so this area can be expanded by its own depending on the object creation. Okay, and method area and heap area are shareable both shareable memory areas. Okay, so these are the things for method area and heap area. So if we will be moving forward, we will get some explanation about the Java stack area. Okay, so this is the method area and this one is the heap area. This is the virtual machine, the Java virtual machine. Okay. So we are good. These are the 5 areas are there. Okay. So moving forward, we have now Java stack area. Okay. In this runtime area, all Java methods are executed. Okay. In this runtime, JVM by default creates 2 threads. They are main thread and garbage collector thread. Okay, garbage collector thread. Okay, these 2 threads are by default created by JVM in this runtime area. Okay, so what is main thread? So it is responsible to execute Java methods Java methods with the method starts with main method. Okay. Also responsible to create objects in heap area. Okay, heap area. If it finds if it new finds new keyword. Okay. Any methodology. Okay. And what is garbage collector? Garbage collector thread. So it is responsible to destroy all unused objects, all unused objects from heap area so one thing you like to know, like in C++, we have destructors to destroy the objects, but in Java we don't have. Like in C++, in Java we do not have destructors to destroy objects. So for each method execution, JVM creates separate block in main thread. Technically, this block is called stack frame. This stack frame is created when method is called and is destroyed after method execution. Okay. So taking one example, uh, yeah, there is a class is there, class test is there. Okay. So in this class test we have like static int x is there. Okay, then we have non-static value z is there. We have a static block is there. Some SOPLN statement is there. Okay, and we have non-static block is also there. So Mesopalian statement is there. Okay, and we have like static method is there. Here is a initialization of. Okay, so we got this, and let's take a parameter through here d. Okay, and we have public static void main method is also there. Okay, string array args is there. This main method will be initializing equal to new example will be there. Here in the class level also will take example e1 is equal to new example. It is also there, and in here we will be calling the m1 method. M1 method is invoked with some value will be passing. Okay, let's see how this class is being executed. First it will be loaded, then it will be executed. How these things will be done in the JVM architecture. Okay, okay. So here I will create the class object. I will create test equal to new test will be there. Something like this will be there. Okay. Okay. So this is the test class is there, and we are writing one example. So example class will be here. Class example will be there. Okay. Some dummy class. Okay. So if we are just loading up this test class, okay, this is the JVM architecture. I'll create. Now we will be reading about the three parts. Okay. So like The parts is we will be reading like those will be, one will be method area, okay, and another one will be like heap area, and the last one will be like Java stack area. Okay, this one will be like method area, like heap area, Java stack area. Okay, when the class will be loaded, class will be loaded means class will be loaded. Loaded means it is compiled. Is compiled means its byte code is generated and it is ready for execution. Okay, so dot class we are sending, dot class we are giving to JVM. Okay, that is the meaning of that. Okay, so here when the class will be loaded, so the test class will be loaded. So when the test class will be loaded, a object will be created. Object will be created of whom? Object will be created of java.lang.class. That is a class is there. Okay, class is there. That name is class. So a class object will be there. Class object will be there. Okay. A class object will be there. So inside it, we will have a object for. We will have the. Well, sorry, we will not have the object. We will have the class will be loaded. The class test will be loaded. This is the test one. This is test dot class. Okay, this will be loaded up. So in the test class, when the class will be loaded, what I told before, all the static variables will be getting memory. All the static variable. How many static member are there? Sorry, static variable are there? Only one. So this one will get memory here. What is the name? That is x. So x named variable, named memory location will be there, like here 0 will be there first. Okay, first 0 will be there, then later on it will be reinitialized with 10. Okay, this one will be there. And any other static member is there? Yes, we have static block is there. So this static block will be also present here. Okay, and all other names will be there, like static, all other names will be there, like m1 main, all the names will be there. It will be not executed here, even though static will not also be executed here. So the names will be there. Okay, m1 will be there, just only declaration. Main will be there. Okay, just declaration will be there. And the static one, this one will be executed. Static block will be executed, and the SOPLN statement in it will be just displayed on our console. Okay, this one will be executed. So after that will come for the, then the JVM will call, JVM have the syntax for the main method. So it will call this method. When this method will be called, so a thread like JVM creates two thread. That is, one is main thread, another one is Java collector thread. Okay, sorry, garbage collection thread. So here it will create a thread, that is main thread. Okay, this thread name is main thread. Okay, so here the first of all the main method will be executed. So when a method will be executed, a stack frame will be created. So inside the main thread, so first of all the main method will be executed. So a stack frame will be created for main method. Okay, sorry, the stack frame will be not here, it will be here only. Oh, not exactly, one above another will be there, but let's create here. Here the main method will be there. Okay, main will be there. Okay, so first statement is that we are creating a object for the example class. So up to this part example E, this variable declaration part, here a memory will be created for that only. E will be there and a memory will be there. Okay, and then we have new example is there. So for new it will create object in the heap area. Okay, some address will be there, and like it will be here the address will be stored and it will be pointing to this one. Okay, this is a local variable. Every time the reference variable, even though it is declared, the non-static variable is declared in the class or the non-static variable is declared locally, in every time the reference variable will always be stored inside the main thread, and the object will be created in always the object will be created inside the heap area. But if the non-static variable is a static one, then the reference variable will be stored in the method area. Okay, inside the class object. Okay, dot class object, inside that the reference variable will be there, and always, like you can say, like in every situation the object will be created inside the heap area. Okay, so after that we are calling m1 method. Okay, so for m1 a stack frame will be created. Okay, for m1 a stack frame will also be created like this inside the JVM. Like this it will be created. Okay, then the m1 method we are passing some argument here, 66. So with passing of 66 the int d will be initialized. So the d memory will be created. So it will be initialized with 66. Okay, like this. Then in the next line in the m1 method we have int b equal to 60 is there. Okay, so a b memory will be created. Okay, and like here inside it 60 will be assigned. Okay, so after that m1 method block and means a block end came, means a closing bracket for the curly braces it came. So the m1 method execution is completed. When the m1 method execution is completed, its stack frame will also be destroyed. Okay, But before destroying of the stack frame, this memory will be destroyed. This one will be destroyed. After that, this stack frame will be destroyed. Okay. So after that, the control came back to this line executed, then this line executed, then comes this line. Test class object is being created. Okay. As I told, the declaration for the non-static variable, always the reference variable will be inside the Java stack area. Okay. So inside the main method, like T will be there. We have a memory will be there for that reference variable, and an object will be created, okay, for test. So object reference, let's say we have 2020 is there, and this 2020 will be stored in this, and it will be pointing. But while the non-static variable of the test class will be created, in the example it's a empty class, so we're like nothing is being loaded here inside this object 1010. But inside the test, we have the non-static variable int j is there, int z is there, and a non-static variable like example e1 is there, and a non-static block is also there. Okay. So first of all, the non-static variable will be declared, not initialized, declared. Then the block will be executed. Then like z, e1, this one will be declared. Then the block will be executed as top to bottom, as in the sequence top to bottom. In that sequence only it will be executed. After that, the initialization part will come, like z equal to 20 and e1 equal to new example. This one will be there. So these things will be created. So like z equal to 20 is there. Like z 20 is there. Another one is there, like example e1 equal to new example is there. So sorry, yeah, the non-static variable, I just told a wrong statement. Like the non-static reference variable which will be declared in the class level, those reference variable memory will be inside the object. Okay, inside the object. But those non-static reference variable, those are declared inside, those are declared and initialized inside a method. Those reference variable memory will be in the Java stack area. So here for the E1, a memory will be created. Okay, like the name will be assigned here, Z will be there, and here E1 will be there. Okay. After that, the non-static, like it will be like initialized with default values at first. 0 will be there, and here null will be there. After that, we have non-static block is there. So for that, a stack frame will be created, because block is also a method. Okay. Non-static block. Okay. Here the SOPLN statement will be executed. One SOPLN statement is there. That statement will be executed here. After that will come. After that, that block, this block part, this block part, this part execution is finished. So this will be, so this part will be also destroyed. Once the execution is finished, then that stack frame will be destroyed to optimize the memory and for better utilization of the memory. Okay, for better utilization of the memory, these things are there. Okay. So after that, after the block execution, is there any class level non-static variable is there, or any block is there, non-static block? No. So the initialization part will be there, like z equal to 20 will be there and new example will be there. So this one will be 0 will be replaced and we have 20 will be there. And for E1, one object will be created, new example object. Okay, object will also be created here. Let's say it is 222. So like here the null will be replaced. As example, class is empty, so nothing need to be initialized here. So here 222 will be there and this one will be pointing to this. Okay, so all things are set. So after this, is there anything is there like no non-static part we are leaving for test class? No, all the non-static members are initialized and executed. So the control came back to this line. Okay, after this the main method curly braces came, end curly braces came. So the main method will be destroyed. So before destroying the main method, these variables will be destroyed. This variable should be destroyed. After that the main method will be destroyed. Okay, the main method will be destroyed. Once the main method will be destroyed and these object t object and example object, these are now unreferenced object because no reference variable are being hold, no reference variable are holding these objects. So these are now like orphans. So sorry, like these are now like unreferenced. So nothing is holding up here. No reference variable is holding these objects. So as nothing is pointing to this, okay, as per our rule for the non-static, this one will be ready for garbage collection. One garbage collector thread is there. Okay, so this one will be garbage collected. Okay, so this one will be destroyed, this one will be destroyed, and also like after the garbage collection this part will also be destroyed. Okay, class object will be destroyed and at last the JVM will be destroyed. Okay, the total JVM will be destroyed. This is the flow. Okay, please go through the video multiple times if you are not able to get, and write also from your side, write multiple program and try to draw like it's not as it not a thing like you will draw only one time and you will get all the things. No, you have to draw it multiple times, like 10 to 11 times maybe minimum, to get the hold of it. Okay, after some practice you will get like how the things are being executed and how the JVM architecture works. It is like very important thing. Okay, you can tell, because if you are able to analyze what JVM do internally, then you can write a perfect code with minimum consumption of memory. Okay, thank you.